Okay, now just to review what we did, because distance students also see this. Everybody did quite well in this class. Everybody got both of these. These are the course ID and key for a late assignments page. And the late assignments page is one where anytime during the semester, you can redo an assignment or do the assignment for the first time and get at least half credit. Okay, so make sure everybody gets that. And I'm really addressing distance students. So I kind of said this to everybody here. Okay, then we have 3/4 times 5/8, and I do want to just go through this in detail. 3/4 times 5/8. That's a multiplication. You multiply the numerator, 3 times 5, multiply the denominators, 4 times 8, and you get 15 over 32. Now, to add 3/4 and 5/8, well, write it out completely. Of course, if you watched the end of the first video, seen the way we do this. We've got to get the same denominator. So we have to have a number that's divisible by both 4 and 8. Well, this one's pretty simple. It's obvious that 2 times 4 gives you 8. Okay. So 4 goes into 8 twice, and we can then multiply the numerator by 2 and the denominator by 2, just like multiplying by 2 over 2. 2 over 2 is just 1, so that doesn't change the value of this fraction, it just changes the way it looks. Anyway, we do that, and then we have 5/8. And then 3 times 2 is 6. 5/8 versus 5, so we got 6/8 plus 5/8. So the question is now, we got everything in eighths. How many eighths do we have? Well, we got 6 of them here, 5 of them here. So we got 6 plus 5 eighths. We don't add the eighths. Okay. Then we end up with a fraction that has a different value. That's 11/8. And a lot of people change that to 1 3/8. And of course, I guess. Open Math does ask you to do that sort of thing. We don't do that much of it in this class. Mixed numbers aren't all that relevant in algebra, okay? But they're important for arithmetic, so let's be complete and do that. I'm not sure. See that very edge of the board, but there it is. Okay? All right. And then people in class, not everybody wrote out all these steps, but everybody understands because everybody got it right. Okay? But do remember to write out all the steps. Like when I'm grading, you're much more likely to get a little bit of partial credit if you show me what you did. And if it halfway makes sense and you just wrote a wrong number or something, I might not even penalize you, depending on the situation. If I do penalize you, it might not be that much. Okay. Now, the next assignment is just continuing what we did here. You find a common denominator, and then you can add the numerators. Okay. So I'm not going to talk about that because I think Open Math covers that nicely, and it's really a 5th grade topic. But as I've said, you learn it in 5th grade, and then somebody puts a calculator in your hand, and you never do it again. And people come out of high school not knowing how to do anything with fractions, not understanding them, and it gets in the way. So we want to get that out of the way real quickly, even though this is an intermediate algebra class. We're doing a lot of review of things that I find people don't know when they come in. Okay. So, the next thing we want to talk about is order of operations. Now, I'm going to just do order of operations. I'm going to write a problem here. First of all, what do I mean by 2 carat? Call it carat, not the kind you eat, C-A-R-A-T, like the way you measure value or the weight of a diamond. Okay. It's carat, C-A-R-A-T. Name of the symbol, has nothing to do with diamonds. But 2 carat H. Okay, if you were to put that in your calculator, we don't want to use a calculator to do that. What would the calculator tell you for the answer? Just give everybody a minute to see if they can do that. Okay, so this can be written in several ways. A lot of people wrote this, which is absolutely correct. And that follows off on what you've seen me do with exponents, right? Okay, so we've got this, and that can also be written 2 raised to the 8th power, right? Okay, makes sense? All right, so we want to know what that notation means. It's going to come up here. Put this one out step by step. Good luck, because the majority of people don't get this right. And we want to clarify the order of operations. But if you remember, like, I think it's a PEDMAS. Just a little hint. Okay, again, if you're a distance student, you need to be doing these before you see the answer. Okay. Okay, so what we do here, now what's the rule? Well, we have a multiplication and a division, right? So we do multiplications and divisions in the order they appear. Which means, first thing we do is 3 times 2, which is 6, divided by 5 plus 7. Okay? Now what's 6 divided by 5? Well, that's just 6. It's you divide, if you have a fraction, you mean the numerator is divided by the denominator. So if you're not really clear on that, if that doesn't ring a bell, if it doesn't make a light bulb go on, make yourself a note to think about that every day for the next few days. Okay? You get it in your head. It's very important. 10 plus 7. Well, following what we did here, that's 6 over 5 plus 7 over 1 times 5 over 5. I'll write it like this. But when I multiply this out, I get, first of all, I get 6 over 5. When I multiply this out, I get 35 over 5. So that means I got 6 fifths and I've got 35 fifths. That means I've got 41 fifths. 6 plus 35 fifths. And do try hard to understand the words that I'm saying, because it should stick with you. Much better than if you don't. Okay? It's very common sense. How many fifths and how many fifths? Well, this many plus this many fifths. Okay? And that's addition and subtraction tend to confuse people with fractions. So you can avoid a lot of confusion. And I'll hope you will. Okay. And you got another way to avoid confusion, that's fine too. Asking ChatGPT to avoid the confusion for you is not a good idea if you stop at that point. Okay, go to the point where it becomes natural. Again, fractions are going to be very important. In the order of operation is universally important. Okay, try this one. Okay, we're doing pretty well here. There are a few things, some steps being left out, and as a result, some people are getting wrong answers. But the order of operations, everybody's got the order of operations correct. And that's really one of the 2 main things, but we do want to understand fractions. So okay, 2 divided by 6 is 2 over 6. Just like 2 divided by 5 was 2 over 2/5. Sorry, 6 divided by 5, 6/5. Okay. So we have this. Now, got to get the same denominator. Everybody knows that. Okay. But not everybody did it correctly. I think everybody sees that the common denominator has to be 6 because neither one of these, each of these actually has a denominator of 1, right? Anytime you have just a plain old number, you can write it as number divided by 1. Because 3 divided by 1 is 3. How many ones does it take to make 3? Well, it takes 3 of them. Then we have 2 over 6 plus 7 over 1 times 6 over 6. Okay. Now, if you haven't done, one person has done the next assignment, I think. So a lot of you haven't. So, this is going to actually help you with the assignment on, the next assignment after the one you've done. So if we do these multiplications using the rule for multiplication, we have 18 over 6 plus 2 over 6 plus 42 over 6. What's that equal? That equals, 18, 2, and 42 sixths. That's 18 plus 2 plus 42 over 6. And that's 62 over 6. And that equals 31 over 3 because we can divide both the numerator and denominator by 2. Okay. Now, if you're a little rusty on that, the assignment will get you up to speed. Okay. Okay, let's try this now. A little more confusing, plenty of opportunities to make an error. So try to avoid the pitfalls, but almost always people are going to run into at least one pitfall in this. So don't feel bad if you do, but you can feel very good if you get it all. Okay, can't say I'm surprised, but if I am, I'm pleasantly surprised because everybody got this. Unless I'm looking at it wrong, so let's make sure. We got 5 plus, now you want to write it out in standard notation. And until I get to 2 to the 4th, I'm going to leave the division sign there. You can combine it if you understand. That would be okay. 2 to the 4th is 16 over 2, and everybody got 2 to the 4th, right? Because we talked about exponents last time. You probably knew it already. Okay. Minus 3. That's going to be 5 plus 8 minus 3, which is 13 minus 3, which is 10. I think everybody nailed it. Okay. And hopefully, if you're a distance student, you stopped when I gave the problem, you worked it out, and then when I worked it out, you recognize that you've done it correctly, or if you didn't, you learned. Okay. Because, the rule is first we do the exponent. Now, a lot of times I'll give this to people to divide the 4 by the 2 because it's easy to divide 4 by 2, right? But you can't do a division involving a number that has an exponent, an exponentiation. Okay? You have to do exponents first. Then multiplications and divisions in order, kind of the way we did these 2 problems. Then you do additions and subtractions. Okay? And open math is going to tell you that. You probably already know it because you're pretty good at it. Okay, so that's all I'm gonna say about that. That's all I see people really needing at this point. Open math will probably tell you a little bit and give you a bigger variety of problems. Okay? But we're gonna move on to the next topic, which is order of operations. So you have order of operations with fractions to reinforce the work you've done on fractions, okay? Then you have just plain old order of operations, which is probably somewhat even easier because you don't have the fractions. So those two assignments shouldn't give you a lot of trouble, but they're worth the time you spend on them. All right. Well, after we get that, we actually start getting into a little bit of algebra. So far, this is just arithmetic. And, you know, arithmetic's not something you want to dismiss. It's kind of important stuff. And there are things people find confusing about arithmetic. Very often order of operations, but as I say, they're great. Okay, next thing is one-step equations. We're going to solve an equation, right? Now, to solve the equation by using the rules of algebra, you can look at the equation, I think, and see what number x has to be. And if not, well, use the rules of algebra anyway, and we'll talk about it a little bit. Okay, now everybody, of course, can see what the answer is. 4 plus 5 is 9, so x equals 4. Some people just wrote down x equals 4. Well, what I said, though, was do it using the rules of algebra. If you're a distance student and you haven't done it using the rules of algebra, try doing that before you watch what I do next. Okay, now the way I would write this out is x plus 5 minus 5 equals 9 minus 5. Because I've got my x plus 5 here, I've got my 9 here. So I've got the left hand and the right hand side of the previous equation, and then I subtract 5 from both sides. I kind of prefer this form, but I'll talk about the other form that people tend to use because it's apparently what everybody's being taught. Okay? And it's not invalid, and it's actually more sophisticated, but people don't use it in the right way. Okay? Don't always use it the right way. We'll see what I mean. Okay? Well, then 5 minus 5 is 0. Put this in parentheses. You really don't need this step because you know 5 minus 5 is 0. And when you add that to x, it's going to give you x, right? It's not because the 5s go away. It's because 5 minus 5 is 0. And when you add 0 to x, you still have x. That's the rule. That's the algebra. That's the math of it. So, you know, if you don't understand that statement, go to the video, replay it, write it down, think about it, because it's kind of important. Okay. So this is what you get. Now, another way people want to write it down. Now, if you're going to put a couple of -5s under here, I want the equal sign. Because what you're doing is you have one equation here and another equation here. Now, -5 equals -5 is absolutely true. Okay? Yeah, I think I had a couple of people want to write -5 equals 9 minus 5. No, -5 doesn't equal 9 minus 5. -5 equals -5. Okay? So don't write a false equation. Don't feel bad if you did, but you understand what I'm saying. Okay? And you wrote down what you were thinking rather than writing down a true mathematical statement. Okay? If you're going to write down a mathematical statement, make sure it's a true one. It should be obvious that if you don't do that, you are taking a big chance. Okay? So now if I add the left-hand sides, x plus 5 minus 5, 12, 5 minus 5 gives you 0, we have x here, and 9 minus 5 gives you. Okay? Now I prefer this because I see people do all kinds of bad things here, and I'll illustrate one of them in the next example. Okay? So let's try this one. Okay, take a minute and write out the steps, all the steps you can think of. You might not think of all of them. You'll see them when I do them. But you all do pretty well here, so I wouldn't be surprised if everybody does it. It's all the steps. And I'm going to try to pause this. Okay, now the first class did pretty well in this. And wrote out a good step. Okay. And one person did something that scared the heck out of me, but it was right. Okay, so first of all, don't do anything with this. You've got this here, there's your equation. Don't insert anything into this equation. Rewrite it and then insert it. In other words, leave this as it is and then write 5x divided by 5 equals 30 divided by 5. Now, one person wrote 5x with the division sign 5, 30 with the division sign 5. That's fine. As long as I'm not looking at it from a distance and don't see the little dots in the division sign and get the idea that, oh man, because I see this, I see people thinking that you can subtract 5 from 5x and that gives you x. No, you can divide 5x by 5 and that gives you x. If you subtract 5 from 5x, well, x could be any number. Okay? There's some numbers you could subtract 5, some values of x where you could subtract 5 from 5x and actually get x. There's only one number that's true. Okay? And that's 1. And that's not the solution to the equation. It doesn't work. 5 times 1 doesn't equal 30. Okay, you don't necessarily understand that, but if you do, it's good. Now 5x divided by 5. And then nobody used cancellation here. And that's good because I don't like to see cancellation until everybody is really, really good with the rules, and that's going to take a little more time than we have. So you just have to, I'll tell you what the rules are, but we're not going to be able to spend an hour on it, which is probably what it's worth. Okay. Anyhow, 5x divided by 5 is x. And the reason for that is because 5x over 5 means 5 over 5 times x over 1 by the multiplication. You can see if you multiply the numerators and denominators, you get this, right? And 5 over 5 is 1. Well, x divided by 1 is just x, and 1 times x is x. So for that reason, and not because we like to cross things out with lines, okay, why not cross this one out and this one? I've seen this, and I've seen much worse. And I've never seen a student that gets through pre-calculus without screwing up cancellation half a dozen times or more, usually half a dozen, hundreds of times. Okay. I see it on our assessment tests. I see it from our dual enrollment students. I see it from our students in class. Something's wrong out there. People are not using the rules of cancellation and they're screwing things up. Okay. So I don't want to talk about cancellation. And you technically really ought to be able to explain why this equals this without saying, oh, those 5's cancel. Okay. Anyhow, 30 over 5 is 6. Now, at this point, we start checking. The check is always part of your solution. And when you write out your homework, I want to see checks on the equations. Okay. very simple problems, not most of them no more difficult than these. Okay, they're just one-step problems, getting you used to writing out steps and checking. Okay, usually doesn't take people long at all to get through that assignment. And if it does take you a while, well, then you need to practice. Okay, give it what it needs, because you're in this course most likely because you have a pre-calculus course in your curriculum in your future. Okay. You're starting to build kind of mathematical thinking and sophistication to get you there. Okay, and you're doing pretty well so far. It's a little early to tell how well you're going to end up doing, but stay on top of it. I think everybody's going to do okay. Okay, so anyhow, we have x equals 6. Now we check. We want 5x equal 30. Well, then we substitute 6 for x. So the 6 goes in for x. You just this 5 times 6 is 30. 30 equals 30. The checks that you do on these first problems on one-step equations, okay, are all going to be pretty simple, I think. To get you in the habit of checking and making sure your solution is correct instead of just, yeah, I think that's right. Yeah, what if you did subtract 5 from both sides of this and thought that 5x minus 5 was x, so that x is equal to 25? Because that's what you would get if you're under the impression that 5x minus 5 gives you x. And it's much easier to do that if you write it out like this. Okay. Which is why I prefer this form. But using this form and not making mistakes with it, I'm just absolutely fine. Okay. Use your own discretion. Okay. Geez, I digress so much I forgot what I was saying. What was I saying? Yeah, I think I made the point you want to check this. Let's go to another example. I'm actually going to give you this step. Because I don't think it's going to be a big problem for you. Let's say we have 5x minus 7 equals 28. Go ahead and work this out. Give me your best attempt at showing all the steps and making sure every step follows by valid mathematical operations from the previous. There. Okay. Okay, so we got this. Now, what's the operation we're going to use first? You got a couple of choices. Okay. You could add 7 to both sides. We've got a minus 7 here. If I add a 7 to a minus 7, I get 0. And that would leave me just 5x. Now I see some people kind of imitating what we did here. And I kind of did this just to see if anybody would do, but a couple of you did. Okay. See people divide this 5x by 5. So, you know, they've written out something like this. And I'll label this as a common error. Okay. They've written 5x over 5 minus 7 equals 28 over 5. Okay. Well, that's not going to work. If you're going to divide by 5, you got to divide the whole side by 5. The rule is you can divide both sides by the same thing. Okay. Say this is not equivalent. You divide the whole 5x minus 7 by 5, that is equivalent. This can lead to the solution. There's an easier way. This leads to 5x over 5 minus 7/5 equals 28 over 5. Probably can't read that 8. It's just to show you. Now you've got fractions all over the place, right? And you didn't have fractions when you started. Okay? And that complicates things. It makes it more likely that you're going to make an error. It's not that you can't take this and then add 7/5 to both sides. Okay? And it would work just fine, but it's more complicated than if you just add the 7 to both sides to start. Okay, so let's do that. I'm getting 5x minus 7 plus 7 equals 28 plus 7. Now notice, I've written the left-hand side here. I've written the right-hand side here. I haven't done any magical thinking. Okay? I haven't overthought it. I've just done a simple mechanical thing where I write the 5x minus 7 into 28 plus 7. Let me do it again. The way I kind of expect, hope that you will do it. I write down the equation. That's it, right? Now I can add, subtract, multiply, or divide on both sides by the same number or the same expression. Okay? So the expression I want is plus 7, because that's going to leave me 5x, and then I'm in a situation like this, which is very easy. Okay? So I'm going to put a little circle around that plus 7. And I'm going to put a little underline under the 5x minus 7 and the 28. Okay? So I see at a glance that I've got everything here, I've got everything here, and they've done exactly the same thing on both sides. That'll avoid any possibility of confusion if you're very mechanical about it, but you also want to think about what it means and why it's so. Okay. The equation's in balance here. Okay. It's like I've got first time in my life I haven't had a meter stick within easy reach. Is it worth demonstrating? Now I don't have everything I'd like to have in order to demonstrate this. Let's just try this. Okay, the meter stick is balanced, right? In the middle, well, half meter stick. Guess my finger's crooked or something. Okay, it's balanced, right? Now, if I put a quarter on this end and a quarter on this end, well, I've added a quarter on both sides, right? And it's still balanced in the middle, sort of. Okay. Now, if I added a quarter on one side and a penny on the other side, it wouldn't, it's not even close to being balanced. There it goes. Okay. Don't want to, oh, there goes half my portion. So it's better keeping things in balance. Now, if I took both of those quarters and chopped them in half, it's still balanced, wouldn't it? It'd have the same width on both sides. So I can divide both sides by the same thing. I can divide the quarter into 100 pieces. It would still balance. Okay. Or I could multiply the quarter. I can put 50 quarters on both sides. Be a little tricky to balance, but in theory it'll balance, okay? If I hang them from both sides, it's easier to balance. But that's physics, we won't get into that. Now if I knew where my chalk was, we could go on. Okay. That was really profound. Let me make sure I was really recording. Yep. It doesn't show me. I get 20 minutes into one of the best explanations that's ever been given to students in the history of the universe, and the blame thing wasn't recording and didn't show me that it was one recording. Why did they change that? What is the matter with these people? Listen to me, Zoom. Okay, now. All right. Get the idea? So we do this, and now we have 5x equals 35. We have 5x over 5 equals 35 over 5, leaving us x equals 7. We check. Five x minus 7 equals 28. We substitute for x. If we don't mess up our order of operations, do 7 minus 7 before we do the multiplication, which would give us 0 equals 28, and that's not true. We get 35 minus 7 equals 28. 35 minus 7 is 28. And it checks. Check here. Okay. Again, I want to see the check on your written work. If you're a distant student, I invite you to send me scans or good pictures of your written work. But that's optional for distant students. But it'd be a good habit because distant students, if you're not in class, it's me in your face. It's real easy to cut corners and harder to be successful if you're not very focused on what you do. Judge it yourself. You know your own work habits. Okay. Anyhow, that's enough on equations. And I think you're going to be okay on that. One-step equations. Then there's percents. What's the problem here? What's 25% of 32 and why? Okay, now most people, the only concept they have of percent is a button on their calculator and accept the answer. Again, this is a massive indictment of the way math is being taught, because the concept of percent is so very important. What does it mean to have 5% interest? Well, punch a button in your calculator. Okay, now I know. No, you don't know. You don't know what that meant. You know what the answer is, and that might be enough, but if you don't know what it means, you can't think about investments, you can't think about inflation, you can't think about a number of things that are critical in your life, much less have the understanding of quantity that you get by understanding percents. Okay? Only one person wrote down anything here, no offense, that made any sense. Okay? And it was correct. And then there's a little arithmetic involved. Working out the mental arithmetic. Imagine you got that, but you had a right expression. Okay? What does 25% mean? Well, Percent means per hundred. Even 20 years ago, everybody over the age of 10 knew that percent means per hundred. Did anybody ever even remember hearing that percent means per hundred? No, the word per is way over people's heads. Because it's not being taught. Okay? Calculator, but there might be other things. There's nothing inherently difficult about it. But it's being replaced by a non-thinking use of technology. Take a lesson on that. You know, don't let artificial intelligence replace your brain, because if you do, it'll replace you completely. Okay? In your lifetime. In half your lifetime. Okay. What's 25% of 32? Okay. Percent means per hundred. That means 25 per hundred. There's a picture that goes with that. Here's 0. Here's 100. Draw that for me and show me where 25 is. Okay, everybody put 25 as close as could be expected in the right place. And it's about here, back here. Okay. Some people might have done it like this. Take this whole thing and cut it in half, and of course there's half 100, which is 50, right? I'm going to take this and cut it in half, and half the 50 is 25. As you might know, if you understood this antiquated thing about coins, quarters, and stuff like that. Okay. And 75 is here, but really there's 25. Now, 25 per 100 is the same as 25 per 100 means 25 100ths. Which of course, you can see from the picture, reduces to 1/4. Well, if you multiply 25 over 100 by 32, 25 times 32 is 800. Divide that by 100, you're going to get 8. Okay? Or if you multiply it by 1/4, 25 times, or 32, 1 times 32 is 32 divided by 4. 32 over 4 is 8. Okay? So we see 25%, that means you're dividing by 4. That's all it means. Now, you can always do this, whatever your percent is, put it over 100, multiplied by whatever number. Okay? There's a lot more you can do with percents. Now, I was going to assign percent applications to be due before our next class, but there are already 4 assignments there. They're pretty straightforward assignments. 2 of them are in order of operation. One is adding fractions where you got to get the common denominator. And the other is doing these really simple, but really important one-step equations. Okay? That's a lot of assignments, but I think you can get through them fairly quickly, so I'm going to leave them there. But I am gonna move the 1% applications. Because I think you're gonna have more trouble with it than you are with some other things. That are gonna be due next week. So I just moved that assignment, okay? Now there are 4 open math assignments that you need to work through. This is all review of stuff that theoretically you knew well before you came, so it's not an unreasonable amount of work. I'd like to give you just a little less work over Labor Day weekend. But it isn't an insurmountable amount of work. You should be able to get it done before Labor Day weekend even starts, okay? So try to get done over the next couple of days. You want to have a worry-free holiday. But whatever works for your life, okay? Okay, y'all did pretty well today on everything but percents. Okay.